Hi everyone, this is the live session 3 of Ponzi Topology and BTA Aeronautic course. My name is Shavin and I work in Dr. Matt's Counseling by Mattress. And this is the third lab session, and Professor Sastry is the course instructor for this course. Okay, so that's the thing. Okay, before studying further, so there is one student has been joined. Okay, Mustaq, can you please tell me whether I'm audible and visible properly or not?
Yes, you are audible and visible
Is
too.
the whiteboard visible?
Yes, yes.
Okay, thank you, Mustaq. Okay, before starting further, can you please let me know, do you have any question or doubt from the previous session or in the live session?
No,
Okay, okay. Okay, so we shall continue as usual by solving problems. Okay, so today, 1 minute. So another Atul has joined. So Atul, do you have any doubt or any question from previous sessions?
No, sir.
Okay. By the way, I shared one Google form link in Google Chat. Please submit the Google form back because that will be considered as an attendance for yours for of the session. Okay, so please do consider submitting the Google form. Thank you. Okay, so let's wait for a few minutes. In the meantime, if you have any question, you can ask.
Sir, I have one question.
Yeah, sure. Please ask.
Um, in the PDF, they gave uh, the exercise 1.12.9.
Okay, I don't have the access to the PDF. Can you
Okay.
please show the PDF, or can you please share that somehow is possible?
Let me try, sir. 1 minute.
Sure. Yeah, okay, let me check. Okay, thanks. The PDF is opening now. Okay, which page?
Sir, this exercise was 1.12.9.
So, okay, which page?
Uh,
Tell me the page number.
uh, let me search.
Okay, there is no page number. I understand. Okay, 1.12, 1.12.
Uh, it was module 12, I guess. Eh, yes, sir. Page number 41. Uh, if if you can explain me the
Yeah,
second
okay,
and
let me
third
check the question
parts.
again. Just hold a moment.
Yes, sir.
Page number 48, you said, right?
41, sir. 41.
Wait a minute. The internet is slow. It is take time. 1.12.9 or 10?
9, sir.
Okay, so there are three sub questions. So which one are you asking for?
Second and third. First I did.
Is complete space. Okay. Okay, second question. Okay, let's try the second one first. Okay, so tell me the definition of what does it mean by completeness.
Every Cauchy sequence is convergent in that.
Okay, that's good. Okay, so it is symmetric subspace, compact plus closed. Okay, let me write to the question here. Just hold a moment. Is the blackboard visible?
Yes, sir.
Okay. So, the question is that x prime subspace of xt and this x prime is complete. We need to show what x is closed. Okay. So tell me, for in order to show closedness, what we need to show?
We can show that its complement is open.
Uh, okay, but you need to use the Cauchiness, right? So apart from that, what we can do?
Mm, We can,
In terms of sequence, in terms of midpoint, I am asking from those point of view. No need to hesitate. Whatever you have in your mind, you can tell me. No issues. So there are two. No, no. I mean, no, no. You tell me. I mean, so it is of course that you know the answer. How to show something is close? What is the possible ways? So one what you told is that complement is open. That is correct. But apart from that, what are the other ways of showing the same?
if we can say that that is an arbitrary intersection of some closed intervals or some finite union of closed intervals, direct it somewhere.
In terms of
Can
sequence,
we use?
in terms of sequence, what you can show?
I
See, there are two things. Apart from whatever said is correct, but apart from that, uh, you can show that it contains all of its midpoints, right? So one way is that x prime contains all of its limit points. Correct? This is one way. Another way is to show closure of x is equal to x prime. Closure of x prime is equal to x prime. Okay. Another way is to show if xn is a sequence in x such that the sequence converges to x, this will imply that the point of convergence shall lie inside the set x prime. So these are the three ways by which we can show that a set is compact or not. Sorry, closed or not, right? I mean, this you must know this, correct?
Actually, I was just covering that video where they were teaching definitions.
Okay, tell me one thing. You must have gone through real analysis, right?
Yes, sir.
So in real analysis, by closeness, what do you mean?
In real analysis, they discussed like only closed intervals on real line.
No, no, they means I'm not asking the professor's lecture. I'm asking you must be gone through real analysis in your undergraduate course, right?
Yes, sir.
Yes, that's from that.
But
Forget about metrics, just forget topology. From real analysis point of view, how to show something is closed?
that I don't remember, sir, I think.
Okay, tell me one thing. Forget about this question itself. Tell me one thing. Suppose there is the interval closed interval AB. Okay. Now show that this closed interval AB is a closed set. How we will show?
Using any of the three methods you mentioned earlier,
Whatever I mentioned, you may forget. No, you may forget it. No issues. But whatever you learned in your undergraduate real analysis, from that point of view, how to show this interval closed interval AB is closed?
we can say that since any open ball on its boundaries will not be fully contained in that A, comma B, so it is not open and
No, no.
then
See,
it should.
something is not open does not mean it is closed. Okay. You must
Oh,
have gone through
oh,
connectedness, right? So in order to show
mm,
closeness, you simply can't say that it is not open. You have to prove it is closed. That's what the target is. So tell me
oh.
how to do.
I think, sir, either I am not able to recall it or I have not been taught that thing.
Now tell me one thing. So these three methods, have you not seen these three methods previously? Either three, any one of these three methods. Have you not seen in your undergraduate course
No,
or
sir, I actually I did not know these methods earlier. Maybe I should try, I
no, the
think
point
them.
is that I mean, see, these things are very basic in the real analysis, okay? And whatever the mathematics you are doing, okay. By the way, can you please tell me your background? I mean, actually, you are from industry or you are from academic background?
I'm a BTech student, sir.
Ah, okay, I see.
Yes, in my
So,
third year.
okay, so in third year, in which college?
DTU, Delhi Technological
Nice,
University.
nice. Okay. So tell me one thing. I mean, so you are in topology directly, or you have gone through the previous um, reanalysis, matrix, basic things?
Uh, I did study metric spaces, but in that real analysis course, I'm not sure if they covered definitions properly because
I understand.
sometimes they don't
I
teach
understand the point.
properly.
I understand your point now.
Yeah.
Okay, so that means there is no formal rigorous session of a reanalysis you had not been gone through, right?
Yes.
So okay, so I will tell you a book of real analysis. Okay, so this book actually is written from beginner's point of view. Okay, and I think you should know basic things very well before going to these complicated things. Okay, So believe me, if you go through that book, it will take hardly to 1 month to understand the basic things, closeness, openness, limit point, all the basic things. Okay, hardly it will take 1 month. So I will write down the book. So you, if you wish, you may go through that book. Okay, 1 minute. So this is a book by of reanalysis. It is written by S.K. Mappa. Okay. So this book is written from scratch and it is highly beginner friendly. Okay. You can go through the book first 4 or 5 chapters. Um, the supremum, infimum, openness, closeness, sequence, series, all these basic things. It will take hardly 1 month or maximum 2 months. So then you will get a grasp of all these ideas. Okay.
Okay, sir.
So
Thank you, sir.
yeah. So tell me one thing. Without, I mean, suddenly, what brings you in this topology?
Interest, sir. I think it was interest. I was interested in studying this subject.
Okay, that's good to hear.
And
But the point is that without basic things, it's very difficult. I mean, what I'm asking is there any requirement from your curriculum that you have to know this
no,
kind of
no,
stuff?
there is no
So this
requirement
is
at
only for
all.
self-interest.
Yes.
Okay, that's good actually. By the way, just asking for curiosity, after BTech, what's your plan? Just getting job or putting going into academia?
I'm looking for options for higher studies as well. Maybe like using gate math.
Okay. But I have one question. I mean, you are from BTech background, right? So
Yes.
you have more opportunities, compared to academics. So what brings you in this direction? I mean, the point is that I am currently doing PhD, and I am currently seeing that many of my friends who are coming from BTech, MT background, they have much more opportunities rather than academicians. So what actually brings you in this direction?
Sir,
I mean,
I think
you can answer frankly. No need to hesitate. You can answer frankly.
uh, like I am somewhat exploring also, but I think it's not bad to study these subjects and they might help me somehow later, even if I go in that direction in non-academic fields. But
Okay,
uh,
okay.
but I think I am doing it for interest, and it is probable that I might still go for higher studies, even though it has less options.
See, I mean, if see, if you do it solely for your interest point of view, that is different thing. But if you think like, okay, if you think like this will you may go to higher studies, then you will interest this subject. The point is that from topology, not only topology. Let me be very honest with you. Okay, not only topology. There are many subjects in pure mathematics. Okay, so do you understand what pure mathematics includes, right?
Algebra, for example, differential equations, and topology, of course, analysis,
Okay,
these kind of subjects.
okay, okay, correct. Okay, by the way, this differential equation is not actually entirely pure mathematics. It's somehow actually applied mathematics. It's not pure
Oh, oh,
mathematics. Okay. Now the point is that, for example, this topology and algebra. Okay, these sports subjects has pure background, pure portion. I mean, these subjects has pure direction things and applied direction things. Okay. Now the point is that topology and algebra, these are the two subjects. If you stick yourself in the pure part, frankly speaking, it is hard to do anything with those things. Okay, the problem is that if you think very deeply, you understand that the for example topology or in analysis, in algebra also, if you stick yourself with pure part, then there is no requirement in universities, there is no requirement in job. Okay, so knowing those subjects solely is a disaster. Disaster in the sense that you there is almost very few options compared to other direction. That is the one thing. And secondly is that for example, in topology there is a new emerging subject called topological data analysis. Okay, now the point is that topological data analysis is a different kind of direction. I mean, if you think that whatever the existing topology is needed for doing topological data analysis, that is not the case. It's although the name includes topology, of course you have to know basic things of topology, but not the existing topology too much. It's a quite new field, and that's a demanding field. Okay, so if you are able to get into those directions, and of course that direction involves somewhat data science, I'm not sure, but that's almost the thing. So that will be helpful. Otherwise, if you think that, I mean, since you are in BTech, so you might not have that much amount of exposure right now, but I'm doing PhD, that's why I have a lot of exposure. That's what I'm saying. If you are direct, if you solely think that this topology or algebra have analysis, you have interest and you want to pursue, then it will be problematic for you from future point of view. Okay, first of all is the opportunity. There is very less opportunity. Okay, and if you talk about interest is okay, but if there is no opportunity, then what's the point of having interest? Right, if nobody bothers about your paper, then what's the point, right? So that's the one problem. And second problem, I think you not aware of that. So do you know the fact that for getting job in academia, that is a basic requirement, right? For getting job in academia, you have to write papers. Do you know that?
Yes, sir.
Yeah. So the point is that in pure mathematics, in most of the pure mathematics, okay, not most. I mean, it somewhat depends on the supervisor itself. It does somewhat depends on the your seniors itself and the environment also. But the point is that in pure mathematics, the rate of creating papers is very slow. Okay, what I'm saying is that suppose you are taking pure mathematics as a research PhD. So maybe within 2 years you maybe create one paper, but if your friend is working in some applied portion, he or she may create 4, 5, 6, 10 papers in 2 years. Okay, so that's a real problem actually, because while applying job, even applying for industry using papers, first people look at the number of papers. Why? Because each paper, whatever the paper you have, if it is published, then for each paper, I am talking about, let me talk about university point of view. Suppose you are applying into some university or even abroad for postdoc also, they will first look at the number of papers, and for each paper contains 8 to 10 marks each paper. Okay, so if you have one paper, so you are already out of the race, so it is very difficult to survive from that point of view. Okay, so that's why whatever you do, I mean, so you are doing BTech right now, so that's why you are in your prime time of your life. Okay, so whatever decision you will take, you should think very deeply, you should think, I mean, very cautiously. You shouldn't think like you are only interested, that's why you should do this. That's not the only soul, that should not be the only point of consideration. There are many other lot of things which you should also consider. Okay, that's the thing I want to tell, because there are many things you might not, it is not possible to you to know many things that you will come in the latter stage of this academic life. Okay, that's the thing, and I'm personally working to topology, that's why I know these things very deeply, and this is my fourth year actually. Okay, so having
Okay.
interest is very good, but you should think from opportunity point of view, from job point of view, from post. If you want to do higher studies, then there is a you need to definitely think of postdocs. So those are the things you should consider. Okay, that's what my point.
Thank you, sir.
Okay, so one okay, so what? Okay, so let me solve this problem. By the way, you are doing BTech in which branch?
Mathematics and computing.
Oh, that's good. Okay, so in this problem, we need to show x naught is closed. Okay, so what we will show is that we will show that it contains all of its limit point. That is our target. Okay, or in other words, suppose xn is a sequence in x naught, and suppose xn converges to x, we will show, sorry, we will show that x belongs to x prime. There is no x naught anyway. Sorry for my bad handwriting. We will show that x belongs to x prime. Okay, that's what the target. Okay. Now, since the sequence xn converges to, sorry, since the sequence xn converges to x, that means what? The sequence xn is Cauchy. Do you know what does the Cauchiness mean?
Yes, sir.
Okay.
Every
Hmm. Tell me.
Sir, it's that property, right? D of xn comma xn plus n less than epsilon for
Correct,
all
correct,
n
correct,
greater
correct,
than t.
correct, 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 right. So xn is a Cauchy sequence. Now our hypothesis tells that x prime is complete. It is the given hypothesis, right? That means that means that means so x prime is complete. That means the sequence xn converges in x prime. Okay, but the limit of a sequence must be unique. This implies what? This implies x belongs to x prime 1. So argument goes as follows. So we started with a xn as a sequence in x prime, okay, and suppose the sequence xn converges to x, we need to show that x belongs to x prime. That is our target in order to show something is closed. Okay. Now, since xn converges to the sequence xn is a Cauchy sequence. Okay. Now, being Cauchy, x prime is complete also. I mean, sorry, xn is Cauchy sequence, and given the hypothesis, the x prime is complete. So this Cauchy sequence converges in x prime. So the sequence xn converges to x prime by the hypothesis, but the limit of a sequence is unique. So that tells that our by we have, but we have already assumed that this sequence xn converges to x, but limit of the sequence unique and that limit must converge to x prime. So x belongs to x prime. So that tells that the little x converges to x prime, which was our claim actually. So that's what the target is. So do you understand the argument? No need to hesitate. Maybe you understand argument.
Sir, x belongs to x prime. How
Hmm.
does that mean that x prime is closed?
Yeah. Okay. Then 1 minute. So here in the screen you can see 3 criterias, right? Last one,
Okay.
the sequence.
Third criteria.
Yes,
Okay,
yes,
okay,
correct.
sir.
So that is
Okay,
one
sir.
way of showing something is closed.
Okay. Thank you, sir.
Yeah. And there is a next question. Okay. So the next part reads as follows. we need to show that the partial converse is true. That is, if xt complete, x prime closed, okay. Now in the next problem we have xd is complete and x prime closed. We need to show that x prime is complete. Okay, that's what our needs to show. So now we need to show in the same question, we need to show that the bigger space, I mean the mother space is complete and the subspace is closed. So in that, so basically it's telling the closed subspace of complete is complete space. So that means what we need to show? Tell me. We need to show something is complete. So what we need to show?
We need to show that we need to take any arbitrary Cauchy sequence in X prime, and then we need to show that it converges.
Correct.
What I understand.
Correct only. So we start the Cauchy sequence. So let xn be a Cauchy in x prime. Now it is given that the bigger space x is complete. That is the hypothesis. So that means what? The sequence xn converges in the bigger space, right? Because complete means convergence.
Yes, sir.
Yeah. So let x be the limit of xn. Okay. But the sequence xn, all this term of sequence xn lies inside x naught. And x is the limit of the sequence. This implies what? The x belongs to closure of x. Sorry, there is nothing x naught, there is x prime only. So that implies what? X belongs to x prime closure. But in the hypothesis, it is given that x prime is closed. That means what? That means x prime is equal to x prime closure equal to x prime only, due to the hypothesis of the closeness. So that means what? X belongs to x prime. So what we have started? So we have started with a Cauchy sequence in x prime and found out that that sequence converges in x prime. So that tells what? 1 minute. Uh, so that tells what? That tells Cauchy sequence convergent. Are you understand?
Yes, sir. Yes, sir.
Okay. By the way, here is the power cut. So um, in case for a few moments I might be unavailable. If there is no power, then the router how it will can. Okay. So please, sorry for the inconvenience. Okay. Okay. So now, so are these two problems clear to you?
Yes, sir.
Okay. So do you have any more doubts? Please don't hesitate.
No, sir.
Okay, in that case, we shall move on. Or So today we shall go through continuity. So have you started continuity in your analysis course?
Sure, in video. Yes, sir.
Okay. So okay. So let's hold on. Okay. So today we shall go through the continuity. Have you studied continuity in the metric space or only reanalysis?
Both, sir, both.
Good. Okay. So in metric space, in topology, since there is no distance function, so of course the matrix, the definition of continuity can't involve the epsilon ball definition. So here we have the definition as the inverse image of open set is open. Okay, so that's the definition. So let definition goes as follows: let f x to y be a function from topological spaces. Then I mean and choose x. Then if is said to be open, said to be sorry not continuous. If f inverse u is open in x for any open set u open in y. So what is telling? Suppose f is a map from x to y, then f is a continuous if f inverse u is open for any open set u. If inverse u is open, that is the point is the inverse image of open set is open. That's what the continuity means. Okay. So instead of open set, you can equivalently tell that f inverse of f closed in x for any closed set f in y. Okay, that's what the definition for continuity. Okay, now so okay, so so that's the definition, and there are a few theorems, and the proofs are easy, but for sake of simplicity, let me write on those theorems. Theorem 1 is still that So now there is a theorem which goes as follows. Suppose f is a map from x to y. Then the following are equivalent. F is continuous. The for any subset A of x one as f of a closure sub of f of a whole closure. So and third statement is that for each x belongs to A and for any open set V containing f of x, there exists an open set U containing x such that f of U is subset of P. That's what the continuity gives. So there are three statements. First one is that f is continuous. This is same as saying that if you consider any set A which is a sub of x, then f of a equals sub of f of a whole closure. And third is that for any x belongs to any open set V containing fx, there is an open set U containing x, so the f of U sub of V. So these are things by which we mean continuity of f. Okay. Now, okay, I am not going to the proof. You can find this proof in any textbook. We need to solve few problems in order to get a grasp how do you use
Can
this.
you please scroll that screen? I'm
Yes, yes,
getting one screenshot.
yes, sure. Okay,
Okay, sir.
okay, so let me tell you the 1 minute. Hold on. So let me share you the references in which this particular theorem is shown. So the reference is there is a book called Topology by Moncrief.
Sir,
Yeah.
I'm referring the book Topology by James Moncrief. They have given another one condition. There are four conditions.
Okay, there are four conditions. You are correct. I am not denying that. But the point is that that's what I have initially mentioned in the definition, right? In the definition, first definition was that inverse image open set is open, and the second equivalent statement was that inverse image of closed set is closed. That's why in that particular next theorem, I did not mention the fourth condition.
Okay, sir.
Yeah. Okay. So that's the theorem. So I mean, let's not prove it. So we need to use the theorems in order to
Sir,
prove all.
another doubt.
Yeah. Tell me.
We have discussed this theorem in my previous classes. On that, my sir told that we can't prove that equivalence between f inverse of b is closed in X and for each x in X and each neighborhood v of f of X, there is a neighborhood u of X such that f of u is subset of v.
Okay. Can you 1 minute? Which problem are we exactly talking about? Let me open the device. 1 minute. Exactly. So, are you so last session we mostly talked about Hausdorff spaces, isn't it?
Yes, sir.
Okay, so they are exactly which problem are you talking about?
In the book, Penshama 104, Theorem 18.1,
One minute.
on that,
1 minute.
for a,
In the book means are you saying in the Mankres book?
yes, sir, yes.
Page number 104.
Yes, sir.
Okay, yeah, there's the example 4 and 5. Which one are you talking about? There are two examples.
On that, the theorem which you have given in this
Yes,
class
yes, yes, yes,
was given.
yes.
On that, we can't prove 3 to 4 exactly. But equivalent means we can prove from anything to anyone, right, sir?
Yeah, correct, correct, right.
But we don't know why it is not proving.
No, I mean exactly what is the problem? That what I am unable to understand. So from which point to which point is the problem coming in that
I
particular
can't
theorem?
prove from 3 to 4, sir.
Sorry, you can't. From which you want to prove 4?
I have to assume that for every closed set B of Y, the set F inverse of B is closed in X, and I have to prove for each X in X and each neighborhood V of F of X, there is a neighborhood U of X such that F of U subset of V.
Okay, so for that you okay. So from 3 to 4, in order to prove that, you need to use the fact that the 3 implies that open set inverse image is open. From that only you can prove 4. Without going that step, you cannot directly prove 4.
Okay, sir.
Yeah, I mean it is although it is equivalence relation, but it does not mean that it will follow the order of the equivalence. Okay, I mean, so point is that from 3 to 1 you need to prove, and then from 1 to 4, and then from 4 to 1. I mean 1 and 4 are equivalent. 1 and 4 you can directly prove, isn't it? So in that way the 4 can be proved via 1 only.
Okay, sir.
Yeah.
Now it's clear.
Okay. Okay, so so there are very basic things like constant maps are continuous, composition is continuous. Let me just write it down. So let X, Y, Ez be spaces, then the following are true. If X to Y, I mean the point is that, I mean so there is nothing more to it. Constant map continuous, composition of continuous map is again continuous. Third one is, so if A is subspace of X, then the inclusion I is continuous. So these are the basic things. Okay, So these are the one of the fact. I mean, so one fact you might not have seen previously, that the inclusion map is continuous map. So inclusion means a is the sub of x, and so we can consider we have a natural map from a to x. So that's a continuous map. Okay, so that's the thing. So so I hope uh, point one, I mean theorem 1 and 2, those are easy to prove, but can you please unmute yourself to and explain how to prove the point number 3? I mean, how to prove that the inclusion is continuous? Anybody, can you please unmute yourself and let me know? Anybody, can you please unmute yourself and let me know how to prove that the inclusion a to x continuous? It's indeed very easy, it's not difficult actually.
Uh,
Yeah. So you see, in order to show continuity, what you need to show? You need to show that the inverse image of open set is open.
like
So yeah, tell me.
inclusion map is identity map that
Okay, I mean, inclusive map is identity map, but if you,
and
I mean, the point is that suppose what I'm saying, say, suppose x to y you have a map, correct?
yeah
And y to, and suppose it is known that x to y this map is continuous,
yeah
and suppose y inclusion z there is another map y to ez, okay, and suppose y is sub of x. So although if you argue that if we take x and y to be a, that a to a, that map is identity, that understand, that is well known, but you anyway need to show na that a to bigger space, that inclusion map is continuous, it's still right. So that part you can't avoid. Are you understanding what I'm trying to say?
yeah like if z is bigger than,
Yes, yes, so that's what you need to prove.
like we can use standard topology to prove this thing, or
Yes, yes,
for
prove
any
it.
topology it should be proved,
For explain one more time, for which topology are you saying?
like just for example standard topology that in rn.
No, no, not so. Okay, so firstly, X is an arbitrary topological space. Okay, so nobody knows what the topology is in it. A is a subspace of that. That means what the topology of X has. A is the subspace which inherits the subspace topology of X. We need
Okay,
to
okay,
show that
subspace.
topology, that inclusion is continuous. We need to show. So what we need to do? Okay, just can you please tell me what's the background? Are you from industrial background, or are you from academic background?
Like I am from theoretical physics background. Like I'm doing
Okay,
uh,
that's good to hear.
PhD in quantum gravity, but I learned more maths and so like
Okay, that's good. That's good. Okay, so I mean, have you started? So definitely, you must have studied basic analysis matrix space, isn't it?
yeah.
Okay, so
Like
okay,
my main motivation was I was learning smooth manifold from Nakahara, the some mathematical methods book, and then I I
okay.
had sort of difficulty with some differentiability, and so like I want to learn more rigorously analysis and
So these things are necessary for your research, PhD, those kind of things, is it? Or not?
yeah
Okay, okay,
yeah
understand, understand. Okay, okay. So tell me how to prove this inclusion map is continuous. So I mean, so what we need to, we need to use the definition, right? We need to take a open set, and we need to consider the inverse image of the open set under this inclusion map, and we need to consider the show that inverse image is open, right? That's what we need to prove it, right?
yeah
Yes. So start just, so take a open set u containing x. One. Take open set u in x. Okay. Now we need to show what? We need to show I of inverse u. This is open in A. So now, okay. So tell me one thing. Do you know Southwest topology?
Yeah, means like let's suppose if A is a topology, and let's suppose we have a just R topology from minus infinity to infinity, and then we can say that you can also take a subset minus 2 to 5, and then you can say that is also has a topology.
Right, I understand the
That is
point. I understand your intuition. But I mean, mathematically, what is the rigorous answer? That's what I'm asking.
okay. Okay.
I mean, no need to hesitate. Whatever you know, you can tell. No issue. I'm here to tell you the explaining things. So if you whatever you know, if maybe you don't need to hesitate, you can tell frankly, no issue.
Yeah. So I can tell the subset topology. Like let's suppose consider a set M and you have a topology O. So you can say MO is a topological space, and you consider a subset S that is a subset S of M. Then you can define a subset topology as U intersection S such that all U is in the O. Then
Correct.
you can
So that
that is
okay. So that
that
means
is
with respect to the South-West topology, and any open set of capital A shall look like U intersection capital A, right? Or U is some open set in capital X.
yeah, and where U is a like U is an element of M.
Correct. Bigger space.
Yeah, bigger space
Correct.
that
Only.
you.
Correct. Okay, so now tell me, okay, so you know the basic thing. So now tell me the I inverse U is open. That's what I'm going to show. Now, what will be I inverse U? First of all, what is the set I inverse U?
Yeah, so I inverse U is an element from, like, let's suppose U is an element of Z, then I inverse U will be element of Y. So, and we know that open means like
No,
if
no, that's okay. But firstly, understand. Firstly, you have to understand now what is the set I inverse of U explicitly. I
yeah,
inverse
so
U is a subset of capital A. That is correct. But what
I
is that
inverse
set?
is a, like, let's suppose we have a mapping from A is a subset of Y and we are mapping A to Z, right?
Okay.
And let's suppose U is an element of Z, then I inverse U is an element of Y. It cannot, like, we have to prove it's in A, but it can be element of Y.
Yeah, but you need to stick yourself in capital A only. You can't move yourself outside capital A, right?
That we have to prove.
No, I mean, whatever the intuition is correct, but the point is that I inverse of U is a is it lies inside capital A, right?
Yeah, yeah,
So, but there is a possibility, as we explained, that some point might lie outside the capital A. But you need to
yeah.
stick yourself in inside capital A. So, what you need to do? I mean, how you will eliminate the points outside capital A?
By taking
Correct,
intersection.
correct, absolutely. So, I inverse of U is nothing but U intersection A.
Yeah, like we are like inverse image should we take intersection.
Yes, yes, that's what I'm saying. That inverse image itself is U intersection capital A.
Yeah, yeah.
That is the whole I inverse U. Now see that our U was open in X. It is by choice because we started with U open in X. So U intersection A, it is open in capital A with respect to the South-West topology, isn't it?
Yeah, because every element of, since U is an open in M, and then U intersection A is an element of O of like O of in O, because subset O, so that's why it is an open.
Correct,
And
correct, only correct, right, perfect. So this tells that the inclusion map is a continuous map. Okay. So now one minute. So there is a theorem called gluing lemma, and this particular theorem is very useful from problem solving purpose. And not only that, this theorem is useful in other fields of mathematics. Okay, and the proof is not surprisingly difficult. It is very easy. It's just matter of observation. So let me state it. So the name of the theorem is that gluing lemma, and also it is known as pasting lemma. Have anybody seen these lemmas before?
No, sir.
Okay, so let me explain. So suppose X is a space which can be written as A union B, where A and B,
Sir, I have one doubt.
yes,
On proving the above theorem,
one,
why we choose that the topology should be a subspace topology? Is there any reason?
that's what I have written now, that A is a subset of X. Whenever in topology we say something is subset, if we unless specifically mention anything, that means the topology of the subset is taken to be subspace topology for granted.
Okay, sir.
I mean, it is same as saying that suppose we have a topological space X and Y, then what will be the topology in X cross Y? If nothing is stated explicitly, that means the topology in X cross Y will be the product topology. Understand? So that
Why
means,
can't we prove in a standard topology or any other topology, sir?
okay, so do you know subspace topology?
Yes, sir.
Yeah, so if I mean, so what does subspace topology? I mean, what is subspace topology then? I mean, yeah, tell me, what do you mean by subspace topology? Whatever you know, you can tell, no problem. Tell me, what do you mean by subspace topology?
I'll be choosing on topological space and then I'll be collecting on subset from the topological space. Then the subspace topology can be defined as U intersection Y such that U belongs to the topological space.
Okay, so this tells what? This tells how to give a topology of a subset, correct?
Yes, sir.
Yeah, so the point is that this is known as subspace topology. I mean, as you have told, and this is a standard way of giving topology to any subsets of a topological space. Okay, so here in this particular problem, I have written now that A sub of X is topological space. So capital A inherits the subspace topology from capital X. So unless otherwise stated, it will be assumed that the smaller space, I mean the subspace, I mean subset will have the subspace topology. Do you understand? So this is a standard way. It is same as saying like
Okay, sir.
R to the power n has equivalent topology. That is one. There may be another topologies also. So that, but R to the power n, the equivalent topology is standard one. Here, subspace topology is standard topology from the subset point of view. Understand?
Yes, sir.
So, okay, so this is the gluing lemma. So what the statement tells, suppose X is equal to A union B and A and B are closed in X. Minded, these are closed in X. Okay, you simply know, I mean, the closeness is important. And let f is a function from A to Y and G be a map from B to Y, both continuous. Okay, and suppose f equal to G on A intersection B. That means on the intersection of A and B, f value and g value are same. If these three condition holds, then we can define a new function h from x to y, a going to f of a, where a belongs to a, and b going to g of b, b going to b. In that way, this function, then the function little h, 1 minute, oh sorry, part is coming extremely sorry. Yes, then this function little h is continuous function. So how? So what the statement is telling? The statement is telling that we have capital X equal to A union B, and A or B are closed in X. Okay, and F is a map from A to Y and G is a map from B to Y, both continuous. Okay, and suppose F equal to G are on the intersection. That means they agree on the intersection. So we can define a map H, so which is f on the capital A portion, which is little g on the capital B portion, and h will be continuous function. So do you understand the statement of the theorem? If not, you please go through the statement one more time.
Sir, what does it mean that A goes to FA and B goes to GB? Like, is that an ordered way?
No, no, it's saying that, it means that, f is a map from x to y under that map. The point is that, what I'm saying is that x going to y under f, that means f of x equal to y. So this is the fancy way of saying. Are you understand?
Okay, I think we are using that F equals to G here.
What? No,
Uh,
no.
I,
Okay, let me write it down in 1 minute. Let me write it down. Sorry for that. 1 minute. 1 minute. Oh, already. Okay, 1 minute.
oh, okay, sir.
Is it clear?
Okay, now I get it.
Yeah. So
Yes.
previously there is some mistake I realized. So is the statement of this theorem is clear?
So,
Yes, to me.
is this why? Yeah, why? What about why?
What?
I don't know. So, we
What
have
do you?
defined X as A union B,
Yeah.
but I don't know what is Y. It can be anything. Sir.
Yes, as a it. Y is any topological space.
Okay, sir.
Yeah. Okay. So now we need to show that H is continuous. Okay. So anybody please try. And one more thing, we should forget that the statement includes one line that A and B are closed in X. We shouldn't forget that. Okay. Because there are examples we are able to find. You may find in, you can check in internet also. There are examples which tells that if A and B are open we take, then this particular theorem will going to fail. Okay, that's why we can't omit this closeness things. Okay, now please try to prove this. Okay, so
Okay, so like,
yeah, tell me, continue.
yeah, so consider that we have a So we have set x and has topology tau x, and we have a topology y with we have a set y with topology tau y. So we have to prove that for all u in y, f inverse f inverse u is an element of tau x.
Yes, you are correct. But for this problem, instead of showing by open inverse image open series open, you can show it by checking inverse image closed is closed. Okay, because if you look at the statement that tells that those a and b, these are the closed subsets. Okay, so instead of showing
And
openness, you try to show using closeness. Yeah, continue.
now we also need that consider, let's suppose now u is an element of a intersection v.
No, no, in order to show H is continuous, what you need to start? We need to start with a closed set or open set in the codomain side, correct?
Yeah, yeah.
So we cannot start with A. We cannot start with things inside A, right?
Means if close means then x minus a is open.
Yeah, X minus A is open, but we need to take the inverse image of the codomain side. We cannot choose the open set in the domain side, right?
Yeah, we have to take if inverse u for u belongs to y.
I mean we need to choose H inverse of U, isn't it? Not F.
Yeah, sorry, I
Yeah, I understand.
misaligned.
Yeah, I understand.
That h inverse u
Yeah,
means
so
or u in y.
okay, so for this problem, let's start with a closed U. I mean, you can take open U, but it will be complicated in terms of set theoretic thing we need to use. So let's start with closed U, open in closed. Sorry, sorry. Okay. Now we have started the closed set. Then,
Then, but the continuous definition is for the open.
so 1 minute. Let me show you one more time. So here the continuous definition is written. You can see that, right? So in the
Okay, okay.
definition, either you can show open inverse image open series open, or you can show inverse image closed series closed.
I
Any
see.
direction is, I mean, any one way is fine. But this particular problem, this particular theorem, use the fact that the subspace are closed, correct? So that's why the subspace is closed. That's why using showing continuity by taking inverse image closed set is seems to be easy. Otherwise, it will be difficult in reality also. So we start with a closed set of y, and we need to show what? We need to show H inverse of u is closed in X, correct?
Yeah.
So then what to do?
Sir,
Yes, tell me.
if if we have any closed set in Y, then it is for sure that its inverse image X will belong to either A or B.
Its inverse image belongs to either A or B.
I mean any element
Yeah,
in
yeah,
that,
correct,
like,
correct only, correct only.
and we know that X is closed,
X is closed. No, X is not closed.
and
They are
no,
subspace are closed.
X, A and B are closed, so A union B should be closed.
Yeah, I mean X is closed. I mean, why you are saying like that? I mean, it's X is the mother space, so it is closed within itself, right? So, I mean, what you're trying to say, I'm not understanding. I mean, the point is that suppose X is a mother space, so its closure cannot go outside capital X, right? Its closure has to be whole of X. So any set is a closed set. In other words, you have the definition of topology that which tells that empty set and the whole space shall lie on tau. So the complement empty set is whole space. So that tells what? The whole space is closed within itself, right? So basically, what you're trying to say, please tell.
I was trying to say that if we take, say, capital U
Hmm.
is equal to U1, U2 up to UN,
Mhm.
we take H inverse of that. So
One
we,
minute, 1 minute. So U1, U2, UN, from where these things are coming?
I mean, any closed set will have some amount of elements, right?
Okay. So are you trying to
We are
use the,
arbitrarily assuming that it has U1, U2, UN.
but are you trying to show that here, like sequential criteria that we have initially discussed? Are you trying to use that?
No, not sequential.
Okay, so what theorem you actually want to apply?
I was thinking in that direction that we will take any element ui, we will take its inverse. Now, its inverse should belong to either A or B,
Yes,
according to our definition of
yes,
h of x.
yes,
And now means any arbitrary element belongs to either A or B,
correct.
and A and B are closed.
Correct. Yes.
I think we need to establish a link from this. I think I may be wrong. I'm not sure.
Okay, this way it will not work because first of all, you are choosing a point collection of points, countable points from the set, right? We need to show that as a whole in its inverse. Full inverse image is closed. That's what we need to show, right? So that the point is that, see, H inverse of U, this can be written as F inverse of U union G inverse of U. First observe this, is it true or false? First convince yourself that it is the case. You can prove it, no problem, but first convince yourself that it is the case.
Yes, it's true. Just that we should take U intersection A, U intersection B.
Correct. So now, as per our choice, U is a closed subset of Y. So F inverse U is closed in capital X, and G inverse U is closed in capital B. Is it clear? Because F and G are given to be continuous.
Yes,
Yeah. And A is closed in capital X, also B closed in capital X. So this implies that F inverse U, this is closed in one capital X, as well as G inverse of U closed in capital X. Is it clear?
yes, yes.
So they are union. That means what? F inverse U union G inverse U. Your union is also closed in capital X. Are you understanding?
Yes, sir.
Yep. So what we are getting? So and this F inverse u, G inverse u, their union is nothing but H inverse of u. Previously we have seen, right? This equation. So that is what we are getting. We started with a closed set u sub of y, and then finally getting that is inverse image is closed in X. That tells what? That tells H is continuous in X. Clear?
Yes, sir.
Yeah. Okay. So this is called known as gluing lemma. Okay. So we have the next theorem, which tells that the theorem reads as follows. Let f is a function from a to x cross y given by f of a is equal to f1 of a comma f2 of a. Then f is continuous if and only if f1 and f2 continuous.
Hello, sir.
Yeah.
Good evening.
Yeah. Yeah. Do you have any doubt? Tell me. In case if you have any doubt, please let me know. Okay. Let me write it down. So, 1 minute. Okay. So we now need to show f is a map from a to x cross y given by f of a is equal to f1 f a in f2 of a. That is f1 f2 component function. That is the model of the thing. And now we need to show f is continuous if and only if both f1 f2 are continuous. So now please try to do it yourself first. So okay, see, okay. So what we need to do? We need to start with an so there are two directions, of course. So let's assume that f is continuous. Okay, this is what we are assuming. So so we need to show that f1 and f2 are continuous. Okay. So now we need to start with the open set and we need to show that inverse image open set is open, or maybe maybe in another way we can show that. Okay. Okay, so one way is that you can take open set from capital from what where from it from in capital X, and you take the inverse image, show it is continuous. Okay, that is one way of showing, but there is another way of showing which I want to explain. Okay, I mean this is one you can use the traditional way, and another way of showing is that so see so from X to Y we have the projection maps pi 1 which takes a point xy and sending it to x. Okay, and similarly we will have projection maps pi 2 from x cross y to, sorry, where is that, from x cross y to y, x comma y going to y. Okay, now the point is that both of these two maps are continuous. Okay, So can you please prove it? Okay, so forget about the previous theorem. First, try to prove that for any two space x and y, the projection map is a continuous map, because I somehow missed this thing before. One more thing is that in the Google chat, I have shared one Google form. So please submit it. Don't forget, because that will be counted as an attendance. Let me reshare it again. Please don't forget to submit the Google sheet, Google form. Sorry. Okay. So can you please prove that these projection maps are continuous? Anybody please unmute yourself and explain. There is no need to hesitate to it. Anybody please unmute yourself and explain how to show this. Anybody please unmute yourself and explain how to show this. If nobody knows, then I will explain.
Like it's here, it's given that we have a
Yeah, tell me.
like what is given here. We have a given x and y.
So the question is precisely, we have two topological space x and y, okay, and we consider the product space x cross y, okay, with respect to the product topology, okay, and in that,
Yeah,
and then we have projection maps, and then now we need to show that projection maps are open. Sorry, projection maps continuous map. That's why we need to show.
yeah. So again, as
Hmm.
previously, we we take any u in x, and
Yeah, tell me.
then if like since x is a topological space, any subset of u is also an open.
So
Any subset
choose.
in
So let me write it
u.
down one way according to your word. So U is an open in X.
Because X is a topological space, and so and then pi 1 inverse U.
Okay, now we need to consider pi 1 inverse U. Absolutely. What will be this?
Yeah, so like if pi 1 is continuous, then pi 1 inverse U is continuous, right? And so
No, no, 1 minute. Pi 1, that's why we need to show that
yeah,
pi 1 is continuous, right?
yeah, that's what I'm saying. If we have to show pi 1 is continuous, then we have to show that pi 1 inverse U is open in X cross Y.
Correct only.
And and since and so like pi 1 inverse will be, and here again we can take a intersection of x cross y and u.
So tell me one thing. 1 minute. Let me write it down. We have X, we have Y, okay, and here we have our U, okay. So what will be the pi 1 inverse of U? So pi 1 inverse of U contains all those points in X cross Y whose first coordinate element shall belong to U, right?
Yeah, so this will be a strip,
Correct.
sort of
This
a
will be a
strip
full
like.
strip, right?
Yes.
So what this will be? I mean, this pi 1 inverse U, that I understand, but what is this set actually? What is this strip fully? It is nothing but U cross Y.
Yeah, yeah.
Yeah, so pi 1 inverse U is nothing but U cross Y, okay. And by our choice, U was open in X. So U
Yeah,
cross
so
Y, this is
i-
open.
Yeah.
in x cross y.
Yeah.
So this
Okay.
yeah, so this tells what? That inverse image opens it under the map pi1 is open in x cross y. So that says that pi1 is continuous.
Yeah. And similarly for pi 2, we take a horizontal strip.
Correct. Similarly, pi2 continuous. Okay. So this tells that projection is continuous, not only what two coordinate, not only projection. I mean, so you can consider any kind of a projection like if I mean, so suppose you have product of x1, x2, xn, and you are then considering the for m coordinate or any arbitrary m coordinate projection. What I'm saying is that you have the map pi, and suppose your product of x1, x2, xn, and then we have the map from x I1 cross x I2 cross IL. That projection map is also continuous. That's what I'm saying. So similarly,
Yeah.
we have proved this. So there is nothing more to extra. So
Hello?
yeah, tell me.
Yeah. Okay. Yeah.
Yeah, tell me.
Yeah. Never mind.
Okay. Okay. So now let's get back to the original problem. So what the original problem was telling is that okay, so original problem is telling that we have f from a to x cross y and the coordinate functions f1, f2, and now we need to show if continuous if and only if f1, f2 continuous. So we need to show both ways. Okay. So initially we assume that f is continuous, and then we need to show f1, f2 continuous. So so the one way is that you can use definition. Okay, but that is not. But I'm explaining you to another way. So so we have a to x cross y little f, okay, and from x cross y pi1 x. So clearly this full composition will be f of 1. Am I right? By definition, little f, I mean by the problem, if a little f is equal to f1 comma f2, so that implies what? Pi1 compose f is equal to f1. Is it true? Are you with me? Is it true?
Yes.
Yeah. So no sooner we have pi1 composite f equal f1, pi1 is continuous and f is also continuous by the hypothesis. So that implies what? f1 is also continuous. Is it clear?
Yeah.
Okay. So similarly, f2 is continuous. So f continuous implies coordinate function f1, f2 continuous. Now the reverse direction. So assume f1, f2 continuous. We need to show that f is continuous. So please try to do it by yourself first. Take your time. We have no reverse direction. F is f1, f2 continuous. That the coordinate function continuous. We need to show the original map is continuous.
Means if f is like from the r, if you go scroll above, like
Yeah, one minute.
if we know that here f a from x cross y, where f b we know that f is continuous, then
Correct.
f inverse will be also continuous, right? And
Mm. No, no, what I've explained, can you please repeat again?
if f is continuous, then can be f inverse will be also continuous.
No, no. So are you saying that if a map is continuous, there its inverse is also continuous?
Yeah.
Okay, so
Oh,
tell me one thing, the inverse might not even define. I mean, inverse image of a set, that makes sense. But inverse image as a function might not be defined, right? Because a map may
okay.
not
Oh,
be,
yeah,
yeah.
yeah, yeah, yeah. Okay.
Okay, so now think and let me know. Okay, so let me give you a little hint. So first of all, in x cross y, these basis elements. So do you know basis?
N- Not, no.
Okay, I mean, so I mean the basis of a topology. So you have not seen that, right?
Yeah.
Okay, so let me define basis. Okay, so suppose one minute. So suppose X is a non-empty set, okay, and beta is a power set of capital X. Then beta is said to be a basis. Hmm. For all x belongs to X, we will get a element B inside beta such that X belongs to B. This is one condition. Second condition is that if we choose two elements B1 and B2 inside beta with an element from their intersection, then we will get another basis element such that X belongs to B3 subset of B1 intersection B2. Okay, that is a definition. So, although definition looks quite complicated, I admit it. So, let me give you an example. Okay, for the time being, you may forget the previous problem because right now the definition is the main thing. Okay, so suppose you have one minute, you have an so suppose you have a topological space. Okay, and okay, so one minute, let me give an example. So consider R. Okay, and consider the set open AB. So, can you check that this collection forms a basis? So basically, there are two things we need to check. We need to check that if we take any point, uh, we will get an a basis element around that point, as well as
Like,
yes, sorry.
basis, the intuition of basis is to like from there we can span the full set.
Yes, that's what
Uh,
the
uh,
name is
uh,
basis. That means a basis is nothing that I mean the point is that any open set is nothing but the union of basis element. That's why it's a basis.
okay, okay.
Your intuition is correct. So that's what the definition is.
Yeah.
Hello, sir.
Yeah, yeah, let me know.
Uh, yes, sir. I had a doubt.
Yeah.
Yeah, in the last class, I asked about firstly, the graph about path connected, let x comma sine 1 by x, related to topology.
Yeah, yeah, yeah.
Yeah, and you say that
Yeah,
in the
so
next.
sorry, I forgot. I totally forgot. I mean, why? I
Oh,
mean,
it's
so
fine.
you can do one thing. You can drop an email to that. So there is one announcement portal. You can drop an email. So no sooner I get email, I mean, it will stick in my mind actually. Okay,
Okay.
so I don't mind. Next in the next session, I will surely solve that. So I totally completely forgot actually. Sorry, don't mind.
Oh, yeah, it's fine, sir. So, can you tell me about the boundary, like where we have a graph like oscillate near the y-axis or x comma sine 1 by x, the graph. So when we talk about the boundary, like in topological way, like how can we think about it?
Boundary means, are you asking about what is the definition of boundary or boundary of what?
Um, boundary, I mean, boundary of that like closed interval if it takes.
Boundary of
Sorry, sir.
okay, 1 minute. 1 minute. So, so are you asking the boundary of the graph, right? Are you asking boundary of the graph?
Yeah, yeah, yeah,
Okay, let me check that.
yeah. क्या
The boundary is, where's the picture? Okay. So, so what is the definition of boundary? Check.
Can
Closure.
you just scroll above in this page just for a moment? Yeah, yeah, thanks.
Okay, so tell me one thing. So for the topological sine curve, what is its interior? Tell me.
interior?
So you are asking about boundary, right? So what is
Then I need to know about the
yeah? So boundary means the closure. By definition, it is the closure of the set minus interior of the set, right?
yeah, yeah.
Yeah. So and topology sine curve is the closure of already something, so it's a closed set. So we need to determine its interior part, right?
Yeah,
Yeah. So tell me what's the interior of the topological sine curve?
it's interior.
At least intuitively.
Yeah. Okay, let me think 1 minute. It will be the y-axis
Yes.
because it will be a y-axis because the graph is oscillating around the y-axis. And interior means if you take a point
Yes.
on the graph,
Yes.
It means that neighborhood is also inside, like stay inside that graph. Yeah, see. So maybe I don't know exact. Um, can you please put off your mic, please, mic off, Subham? Yeah, yeah,
Okay,
thank you.
so the interior is let me think also. Hold on, hold on. Yes, you are correct. The interior.
Yeah,
One
thank you.
minute. No, no, 1 minute. I was 1 minute. Let me think.
No, I'm confused. Like I'm saying wrong something. That's
Okay,
why.
1 minute. Interior. So
Because after some point, it's like not oscillate, just oscillating around the y-axis.
yeah, yeah. Uh,
And yeah, okay, firstly this.
so see, the point is that it's the topological sine curve. It's lies within R2, right? Correct.
Mm-hmm.
So if interior is not empty, that means what? It should contain at least one ball, right?
Yeah.
But it is a flat thing. I mean, the point is you cannot put a disk, you cannot
And
put
the
a ball
neighborhood.
inside, right? Correct. So
No,
the
no.
interior is already empty.
Empty, empty, empty.
So so interior
So
empty
there
means
is a relation with like path connectedness or connectedness. We will talk about it.
yes, that is yes, but that has not connect. That has no connection with the interior thing, right?
Yeah, the interior point was clear because it will be interior. Yeah, yeah. There is no neighborhood because we are not talking about this.
Correct, correct, correct. There is no ball. You
Yeah.
cannot fit here.
There is no ball. We
But
can't.
mathematically, you need to prove it differently. You can try, or you can drop an email to the discussion forum. Actually, I might forget. That's why today you drop an email discussion forum. I will get back to you with the solution actually. Okay.
Okay. And yeah.
Yeah. Tell me.
And then, sir, in the last meeting, you told me about that Vic took a square like and cut it.
Yes. Yes. Yes.
So like clean bottle something related.
Yeah. There was some
Um,
projective space.
yeah,
Projective space minus a disk was Mobius band.
yeah. We cut a disc
Yes. 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 Correct. I can remember.
and then, yeah.
Yes. So yes. So there. What is the question?
So that question, like, it's not clear, sir. When we are either we are cutting the disc, like we took a disc, and then okay, that figure you
So 1 minute.
told me the last class. This one
Hmm.
is it visible, sir?
1 minute. Hold on.
Yeah.
It is visible.
Yeah, that's
It is
what, sir.
visible.
It's not clear. Like I try to understand again and again, but it's not
I
like
mean,
clear picture. Like what actually we are doing in this.
okay.
Yeah.
So 1 minute. 1 minute.
Okay.
Let me open my note also. Because
Yeah.
hold up. It's first session. So see this.
Yes, sir. This one. This one. Yes, I know. This is the graph.
Yes. Now, yes. Now, so we need to. So the target was to show that uh, Mobius strip. If we put a disk along its boundary, then we will get projective space, right? That was the question. Yes or no?
Wait a minute, sir.
Yes.
Yes, sir. Noted.
Yeah.
Yeah.
So the target was to show that if we have a Mobius band and then
Mm-hmm.
if we put a disk, then it will be the new thing will be project space, right? That's what the target, correct?
RP2 plane.
RP2 plan.
Yes, and then the like direction of arrow, like what's the concept behind it we are putting?
Oh, okay. So direction
Yeah,
of arrow is
that's
nothing. Yes, let me write down. I mean, so uh,
yeah.
suppose we have a diagram like this, and we are putting this arrow in the sorry left side. Sorry, we are putting arrow in this direction. So that means what? That means in this space you are ident 1 minute. That means in this space we are identifying this these two edges in the same direction. That means if we are considering a point x with the distance t, then this point is getting identified with the same point sitting as a distance t in the lower edge. That's what the arrow means. That the arrow tells how to identify these 2 points. Okay. For example, you have seen in torus, right? That in torus
Yeah.
we have put arrow like this and like this.
So it's not visible. Can you
Oh,
please?
yes, sorry.
Yeah.
Ha, yes,
Yeah. Yeah. No. No. It's fine.
yeah. So we put arrow like this, and similarly left, upper and bottom, horizontal
So
axis.
that means the direction is same. Like we want
That
to see.
means this tells that so there are two different kind of arrows, right? Same kind of arrow means those two edges are getting identified, and the direction tells that how these are getting identified. For example, in the left side, if we take a point at a height t, then on the right edge also the point at height t, this will get identified. Then only now we will get a cylinder after identification of the left and right. It is not a cylinder at all. I mean, are you understanding my point? What I'm trying to say?
Yeah, sir. Little bit.
I mean to say 1 minute. So we have a torus like so. Forget about torus. So let's 1 minute. So we have a square, and in square we are putting an arrow in the left and right vertical edges. Okay. So that means this in this rectangle, the left and right sides are getting identified. And how they are getting identified is nothing but if we take a point, I mean the point is 0 comma t, this point is getting identified with 1 comma t. These are all vertical points, right? 0 comma t represent a point here, and 1 comma t represent a point here, right? And these 2 points are getting identified if they are in same vertical height. And so after identification, what we'll get? We will get a cylinder. Is it? It will be cylinder. So that's what by identification means. Do you understand or doubt? Tell me. I mean, by arrow
Uh,
we mean how to identify. Instead of putting the arrow in the direction, we can
and
put.
if yeah,
Yes, tell me.
yeah, if like it's like way two vertical lines
Yes.
or edges, we I don't know how we are defining the terms. Like first that edges and the second was identifiers. Like
I
so,
mean,
if we have like vertical 0 and 1, Then in R2 plane, are we talking about, or in
Haha,
R3
it
plane?
is in art. We are in art two.
Okay.
No, I mean I don't get understand the point. One minute. Hold a moment. Where is what? This other page. So what is this? So this is the page. Okay. Is the page visible somehow? But it got vanished.
Yeah, the background.
It got vanished. Okay.
Yeah.
One minute.
So we are just like stretching that and making it to cylinder like that.
So this is the paper, right? Okay. So
Yeah.
so suppose we are identifying this edge. This is the edge and this is another edge. We are identifying this edge in the same direction. Okay. That means we are putting this edge. We are gluing this particular edge to this edge via same direction. That means we are. I mean we are doing like this. Um, this paper is quite big. We are only gluing these two edges and rest of the thing is hollow inside. We are not identifying any other parts. These two edges we are giving direction in the same. So that means we are gluing only these two in the same direction. If the directions are opposite, then we have to bind it, then we have to glue. Are you understanding my
Then
point?
it will be a
Yes,
Mobius
correct,
strip.
correct, only, correct. It will be Mobius,
Oh,
correct only. That's what the arrow means. It means, I mean,
okay. That's why in Mobius strip the arrow was in opposite
uh,
to.
yes, correct, 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 correct. But for Mobius 2, I don't have anything to show because that will not work actually. Now, are you understanding what I'm trying to say?
Yeah, yeah, got it, got it.
So that's what the only work with arrow. So arrow means how we will glue. That's all. So for example, in our exercise, we have cylinder, yeah.
Yeah.
And now in the cylinder, if we mm, put arrow in the vertical and horizontal circle like this, that means we are identifying those two circle of the cylinders in the same direction. So
Okay.
I mean, so so you already have a cylinder and you are basically identifying these circles in the same direction. So you will get a torus donut like of structure.
Yeah.
So that's what the arrow indicates. It indicates nothing more than that. Are you
Okay.
understand?
And when we like make a took a disc, okay.
Yes.
So or no, 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 took a sphere
Yes.
and we cut a disc from that sphere. Okay. So when we are putting a Mobius band inside that disc, so then what's like again the direction will work or some concept.
Okay. Repeat the question one time.
Yeah.
Repeat the question one time.
Okay. We have a sphere
Yes.
and we cut the disc
You have
and
exactly
we
got the disc. 1 minute.
yeah.
Okay. We have a sphere. Where is the sphere? We have a sphere and we cut a disc from it. Okay, so we will have some
Just a small disc we can cut it like
yes,
from
yes, you can cut a
like
small disc, there is no harm, but what's the point? But what is the question actually?
actually like we have a sphere, okay,
Yes,
and we cut a like circular disc
yes, okay.
and put a Mobius band on that disc.
Okay, put a movie album disc, okay. uh okay, put a movie
Yeah.
album. What is the question? What put a
How to put Mobius band on a like this sphere has no torsion, right? And uh,
from a
like
1 minute.
and Mobius band has a torsion of like
Okay,
Mobius
yes, I mean
Mobius has
when the
homology group
yes, yes,
Z2 some
when
Z2.
she is saying that we need to put a movie as well on the disk, that means this disk has some boundary. I mean, the point is that after removing disk, we have some boundary, right? This is the boundary, correct?
Yes.
This
And
one.
Mobius band has a boundary circle, correct? At least
Yeah.
Yeah.
intuitively. So
Yes.
that
Yes.
means
Yes.
we need to glue those two boundaries, because those two boundaries nothing but the circle only topologically, right? So we
Yes.
can glue two circles, there is no harm. So
Yeah. Yeah.
that's why only that means attaching Mobius strip with to the disk, to a disk minus sphere minus a disk. Okay. Okay, the point is that for your particular question, so you ask that if we attach a Mobius strip with this
On the disk, like
with
on
the
the
after
boundary of
removing the boundary, we'll get the
after
Mobius
removing the.
we'll get the same thing. Why? Because if you think in terms of Mobius band, it is difficult to visualize. But the point is, suppose you have some arbitrary topological space, okay, and you remove a disk from here. So
Okay.
then uh, what it will look like?
Oh,
It looks like this. Okay. Now you are
mm.
attaching a disk. Okay. You can say a disk, or you can say a
Um,
disk is sphere minus a disk. It is a disk anyway, right? Correct.
uh,
Now if we
yeah.
glue these things along the boundary, so what you will get? You will get the same thing again, isn't it? Correct.
Yeah, same thing, but like if we attach or add a Mobius band, then still I want to add a Mobius band.
Hi.
What
Yes.
will change the properties?
I mean, it will not change anything. Mobius band, if we add a disk, it will again do Mobius band itself.
Huh, yeah. Again, it will be a Mobius
Yes,
band.
yes, yes. Now, if you
Yeah.
ask how to prove this, the proving is very deep technical thing. I mean, it is not part of this course itself. I mean, it is very far away from these things actually. For the time being, show, you can see some books which I will tell. But
So, sir,
Mobius band itself, not only Mobius band. If we take any manifold instead of Mobius band, if we take X, any manifold, and then attach a disk after remove boundary, then that will also be that particular manifold itself. Understand?
yeah,
A
and so
huge thing
like,
actually.
okay, yeah. So, and so like you told me that if we took a square or rectangle and we have identified the direction, it will play a like role. If they are in same direction, then we will get cylinder. If they are not in, then we will get the Mobius band by twisting because there will be
Okay,
opposite
okay. Can you
direction.
please repeat?
Okay, we took a rectangle.
Hmm. This one.
Yeah, this one.
Hmm.
And if we had same direction and same arrow in same way,
Yes.
so it we will get a cylinder.
Correct. Correct only.
And if we like
Reverse.
direction or change,
Yes.
then we will get a Mobius band or something, but it will not be orientable like that.
Correct. It's not orientable.
It's,
Correct.
that will not orientate. So when we like make a cylinder,
Yes.
so there will be a direction like in one way. That's again orientable.
Yes. Yes.
Yeah. So after that, when we stretch it or when we will make the torus, okay. So then we will talk about arrow and
Ah. So from so in suppose we have cylinder. From cylinder, if you have to get torus, then you have to identify those two boundary circles, right?
yeah,
So that's what here I have explained that this is this boundary, this arrow, and this arrow in the same direction.
yeah.
The order of, I mean, circle is any point of circle
Clock,
you can element e to the I3, yes, correct, clockwise, anti-clockwise, rather.
clock or
So yes,
anti-clockwise,
so you can glue both circles by clockwise direction. So e to the power I theta in the top circle shall
and
glue to e to the power I theta bottom circle. So then only we will get Mobius band. Sorry, torus.
torus.
Yeah.
Okay. So like there is a much role of that direction and identify
Yeah, there is a much role, but
big role.
yeah, It's a big role, but not that big because this is
Because
the
if we change like a small direction, and it will we will get like non-orientable and orientable. Like we have different
uh,
surfaces.
yeah, correct. That's correct.
So it will like change our theory.
Mm, yeah, correctly, right.
Yeah, so that means then after we can't talk about topology equivalence, because when we identify the direction, like one surface has that same direction, another has a opposite direction. That means one is orientable, another one is non-orientable. That means they are not topologically equivalent. Is it correct?
You are correct. It is not topologically equivalent, but it is not immediate.
Yeah.
You are absolutely correct, but it
But
is not.
we need to identify one property, right, sir?
You are correct. You need to identify one property, but I mean that's what you have explained. Now you told just right now that the orientable is that property itself.
Yes, sir. What, sir?
The orientability itself is the property determining this thing.
So, like if it talking about the particular topic, like compact orientable, that means in that part we have difficulty to find about topological equivalent. Then we can't take orientable as a factor to differentiate. Like
No, orientable is a factor for differentiating two different manifold, one of which orientable and another not. For
so, then
example,
it's a fact.
Yes, I mean Mobius band is not orientable, but cylinder is orientable. That's why they are not same.
Then yeah.
Is it?
Means like
Yeah.
they are not equivalent, and like
Correct.
we say why their homology group
Oh,
are also
first
different.
of all, I realize the Mobius band is its surface dimension. Okay, so that's correct. So Mobius band
And
is
Mobius band also has boundary, right?
yes,
It
but
has on
yes, but boundary here is not distinguishing anything. Only the
boundary
orientability.
also does not matter. Like then there are like
No, boundary matters. I mean, suppose x and y are two spaces which are equivalent topologically. That means their boundaries,
yeah.
their boundaries are also homeomorphic. Their boundaries are also equivalent,
Okay.
and as well as there has to be same they has to be oriented both. Otherwise, not. Otherwise, they are not equivalent. So, what is their question actually?
Okay, sir. No, I got it. Like, we need to, if we want to prove, like, there is a long process.
Okay,
Like,
yeah.
it's, I need to study
but
more.
but if you talk in
And
terms of surfaces, then only orientability matters. But
this go.
but apart from surfaces, for other higher dimension, orientability doesn't matter anymore, because in higher dimension there are examples where non-orientable manifold is homomorphic to orientable ones. So
We
orientability
need
is
to
the
record.
thing which comes only in dimension 2. Apart from dimension 2, this doesn't don't come actually. Understand? And
Yes.
for surfaces matters. For surfaces it matters a lot, but for dimension 5 onwards it doesn't matter. And actually for dimension 5 onwards there are
It's,
different process how to check two things are same. I mean topologically same or not. That is
Yeah,
a different story
like
actually.
I also see that,
sir,
Yeah,
okay,
like
sir. I will discuss in the next class because I have to go.
sure,
That's
sure, sure. Yeah,
yeah.
go ahead,
That's
go ahead.
that's why, sir. Okay.
That's
Thank
fine.
you, sir. Thank you.
So yeah,
like
so yeah, tell me.
like when we do homology group, we have a simple complex, and there is another complex. Like as a physicist, I just learned the simple complex, but for like Allen Hatcher do CW complexes also, and people say that like for physics it is important to do cellulation, and so people say that in higher dimension than 5, simple complex is not equivalent to CW complexes.
Mm, no, in higher dimension, CW complexes can be given a structure of a cellular complex.
Yeah, cellular, that's what I'm saying. Simple means like
Hmm.
people like
Triangles, triangles, polygons.
cellular means triangle. Like for torus you make a sort of four triangles, like you part Like you mean
Correct,
like
correct,
we make a triangle and
correct,
then
correct,
we calculate the boundary.
correct, Nima, correct.
Yeah, yeah. Similar I have one doubt, but maybe like I was just basic about this connectedness. Like we know that when two are connected, like if you have a two topological, if you have topological space X, and if you cannot write in X1 in one in X2, then you say that it is connected, right? But there's another about arc-wise connected that let's suppose they say that consider any 2 point. Let's suppose you have a topological space X and X and Y is an element of X. Then they say that there is a continuous map from F from 0 to 1 closer to X, and if f of 0 is X and f of 1 is Y. But people, but in that book what I was reading, that arc-wise connected is not equivalent to connectedness. Do you have intuition for that?
I mean, arc-wise connectedness. Uh,
Yeah, or I didn't understand what does mean by arc-wise
I mean,
connectedness.
arc-wise connect path connected. That means any 2 point can be connected via a path. That means any 2 point can be connected via continuous map, which start with 1 and ends with 0.
Yeah, like we defined some continuous map from closed set 0 to
Yes,
1
yes, yes.
to X, and but now the book I was reading, he says next that with few pathological exceptions, arc-wise connectedness is practically equivalent to connectedness.
Arc-wise connectedness exactly implies connectedness. I mean, possibly in which book are you following?
There is a book for physicists called Nakahara, Geometry, Topology, and Physics.
Okay, but as per my understanding, arc-wise connected implies connectedness.
But they are saying there's some pathological
I
exception
mean,
to
there is no
that.
exception. That's what the theorem tells. Arc-wise connected implies connected.
Like, do you
Yes,
can you send me the reference for
yes,
that?
yes. There is a reference book. So let me type in chat. What?
So you are saying that both are equivalent, arc-wise connectedness and
Ah, yes, yes. That's what
yeah,
I'm saying.
yeah.
For some reason, it is kept